Hey, welcome back, Algebra 2. And today we're going to go ahead and start off with something a little more exciting. Going on a field trip. Almost all these videos I think have been in the bottom right, and decided to try something new. So how about today, we'll move you up here, top left, see how this changes it for us. So, all right, now that we've got that taken care of, permutations and combinations. Now, these are very similar, except one major difference is, does order matter? Okay, if order matters, then we call it a permutation. If order does not matter, it's combination. So remember right here, these two buttons, NCR, NPR, those are the ones we're going to use, and it depends, does order matter? Okay, so one of the hardest parts of this chapter is deciding, does order matter? So on each of these problems, we're going to first establish, does order matter, and then we can solve it. Okay, so 8 people are in a race, and it says if there are no ties, how many ways can people come in first, second, and third place? Now the key thing here, let me get my marker. First, second, third. Those are distinct differences, okay? First, second, and third are not the same. Okay, one obviously gets you the gold medal, silver, bronze. Okay, they are different. Because those are different, order matters, okay? So a couple ways we can write this. But probably the easiest, just like on the calculator, NPR, because order does matter, okay? So if we put NPR, and then we're going to start, you're always going to start with your bigger number, okay? It's possible these numbers could be the same, but the second number can never be bigger than the first. Okay, there's 8 people total in the race, and we need to find out the top 3. Okay, so NPR. Okay, now, all we do from here, go over here, and we say NPR of 8, 3, and we get there 336 different ways. Okay. So now on the next one, oops, let me put my marker back on. Okay, for the next one, it says, how many ways can a club with 9 members choose a 2-member subcommittee? So right here, 2-member subcommittee. Now, here's the best question for us. Either you're on the committee or you're not. If it's just a choice of yes or no, yes, you're on the subcommittee, or no, you're not, then that means that order does not matter. As you can see on the first problem, it was, are you in first, are you in second, are you in third, or are you none of those? Okay, those were what we cared about. Where on this one, it's either you're on the committee or you're not. Okay, so this is going to mean that order does not matter. So instead, it's NCR. C, remember, stands for combination. Okay, we still start with what's the total amount of people we're choosing from. There's 9 of them. And we only need 2 members, so 9, 2. So all we have to do then is go over to our handy calculator, and let's clear it. And NCR of 9, 2, and we hit equals, and there's 36 combinations. Okay, there's only 36 because all we care about is, are you on the committee or not? If it's a combination, it's going to be less than if it's a permutation. Okay. Now, number 3, a pizza company has 12 toppings to put on a pizza. How many different 3-topping pizzas can be made? Now, if we think about this, let me fix that so we can read it still. When you're making a pizza, there are a few people that might care, but for the most part, we don't care if I put the sausage on or the pepperoni first. As long as sausage and pepperoni are on there, we're happy, okay? You can put it on first, you can put it on second, you can put it on third. As long as it's on there, I'm going to be happy. So, once again, order does not matter. NCR, and there were 12 options, and we're only choosing 3. So, we go over to our calculator. NCR, oops, I got to clear it. NCR with 12, 3. Okay, we hit equals. There's 220 different possibilities. Okay, now the final one up on this top section says, how many ways can you arrange 10 Blu-rays on a shelf? Okay, so if we have 10 Blu-rays that we're putting on a shelf, think about it. The first spot, the second spot, all the way through 10. There's 10 different spots it can be on. We're saying that it's different if it's here or here or here or here. As we move it over, that changes things, okay? How many different ways could I arrange these DVDs in order, or sorry, Blu-rays in order? Okay, so order is crucial for us. Now, in this case, still going to be NPR, and we are arranging, there are 10 total we're choosing. However, we're putting all of them on there. So if we're using all of the items, then it's also going to be a 10 right here, 10 comma 10. So we go back to our calculator, clear it, and once again we're doing NPR 10 comma 10. Now you'll notice on the bottom 10 minus 10, that's 0. 0 factorial we've already said is 1, so it's going to be whatever 10 factorial is divided by 1 will be our answer. Okay, so we hit equals, and it turns out that is 3,628,800. Okay, so this pizza place, or sorry, the DVDs, lots of different ways we can put the Blu-rays on. What was it? 3,628,800, I believe. Okay, so lots of different arrangements for us. Yes, we got that right. And the reason is because each spot, if you think about it, the first spot, there's 10 choices, then 9. Okay, it just adds up very quickly as we get that. So a permutation is going to be much bigger than a combination if it's the same numbers. Okay, now as you can see, that wouldn't always have to be the case. If we use small numbers, our permutation can be small. But if we're using the same numbers, the permutation will be bigger. So now let's scroll down, and one last question I want to talk about. So far, we've talked about the counting principle, combinations, and permutations. And this question is going to kind of combine those. Okay, so you'll notice here we are building a pizza at Pizza Hut. Okay, and we get to choose one size. So for here, we're choosing one size. We're choosing one crust. We're choosing one sauce to be on it. For meat toppings, it says right here we're going to put 3 of them on there. And then we're putting 2 vegetable toppings on. So we're going to choose 3 of these meat toppings and 2 vegetables. Now, we need to multiply each of these different choices together. If we think back to the counting principle, that was where you take each of your choices, and however many choices there are, you multiply together. So if we are choosing one size pizza right here, okay, there are 4 different choices. So on that first slot for size, we put a 4. Okay, now for crust. So I'll put size here. Now for the next slot, this is crust. Once again, we're just choosing one of those. So, sorry, that's not the neatest, but it'll do. There's thin, thick, stuffed, and those are just 3 choices. So 4 times 3. Okay, now our next choice, sauce. Marinara, Alfredo, cheese, or barbecue. Okay, so which sauce are we going to put on our pizza? We got 4 choices, so we put that there. Now for the meat, this gets more complicated because we need to calculate how many possible ways I could choose 3 of them. Now, remember, if we're putting this on the pizza, we don't care about the order. We just care, is pepperoni on it? Yes or no. Is sausage on it? Yes or no. Is anchovies on it? Hopefully no, but we'll see. Okay, so meat toppings. There are 3 of them that we need to choose. So first we count 1, 2, 3, 4, 5, 6 total options. So this is going to be NCR. Remember, we said order does not matter. It's a combination, and we are choosing 3. There are 6 total choices, and we're choosing 3. Okay, at this point, let's go over here to our calculator, and we said that it is NCR of 6, 3. All right, so there's 20 different ways that could happen. So since that one equaled 20, here for the meat slot, we're going to put a 20. Okay, our final one, our final choice is how many veggies are we going to put on? How many different ways can we put the veggies on? So we know from the directions that we're choosing 2 toppings. There's peppers, onions, mushrooms, olives, or tomatoes. So only 5 different choices. Okay, once again, order doesn't matter. If the pepper's on it or the onions on it first, I don't care as long as I have peppers and onions. Okay, so once again, NCR And instead of 6, there were 6 types of meat. There's only 5 types of vegetables that we are able to choose from. So 5, 2. And let's go check what that is. So we change it to NCR 5, 2. And we get 10 different combinations that we can make. Okay. Oops. All right, so at this point, we're almost done. All we have to do now is multiply 4 times 3 times 4 times 20 times 10. Okay, so let's go back to our calculator, clear it, and we said 4 times 3 times 4 times 20 times 10. And when we multiply all those together, let's double check that. 4 times 3 times 4 times 20 times 10. Yep. And we hit equals, and we get 9,600 total types of pizza. Okay. Now, if we think about it, that is only the way we could have these pizzas if we're doing 3 meats and 2 vegetable toppings. Okay. There's lots of different choices, but for our particular scenario, there are 9,600 choices. So go ahead, give today's paper a try. The hardest part about today is just deciding, is it a combination or is it a permutation? Once you have that decision made, it's pretty easy. Just use your calculator to find your answer. Okay. Keep in mind, if you have any questions, please reach out, and I'm happy to help. Have a great day. Talk to you later. Bye.